Yep, hello. Yeah, um, Today I'm going to explain a topic non-recursive predictive parser, which is also called as LL of 1 parser or table-driven parser. Basically, this parser has come in second phase of a compiler where we have two kinds of parsers. First one is top-down parser and other one is bottom-up parser. In top-down parser, we have a non-backtracking, non-recursive. We call it as one variant of non-recursive predictive parser is non-recursive predictive parser, which we call it as LL of 1 or table driven parser. Okay, so how do you check whether the given grammar is LL of 1 or not? First L stands for scanning the, why we call it as LL of 1 means first L stands for scanning the input from left to right, and second L stands for leftmost derivation, and 1 stands for one input symbol look ahead. Next input symbol that we can, when you are parsing the input, we can able to know apart from current input we can able to see the only the next one symbol at a time. That is one indicates that. Now how do you check it? Here is basically top down parsers cannot work on left recursive grammar and left factored grammars. Okay, so in order to check whether the given grammar is LL of 1 or not, first thing what you have to do is you have to eliminate or you have to pre-process the grammar. So in what way you have to pre-process the grammar is eliminate left recursion or left factoring if anything is given in the input grammar. Okay, so 99% both will not be there in a given grammar. Either the grammar may contain left recursion or the grammar may contain left factoring. Okay, so now first thing is that, so in order to construct there are four steps actually. First step is eliminate or pre-process the given grammar. If if the given grammar input grammar contains left recursion, you eliminate it, or if the input grammar contains left recursion or left factoring, you eliminate it. Next step is after eliminating left recursion or left factoring, whatever the output grammar you got it, final grammar, after eliminating that, for that grammar you compute first and follow for all the non-terminals of the given grammar. After eliminating pre-processing, then you compute first and follow. Fine. So third step here is you have to prepare a table consisting row wise and column wise. So row wise you write all the non-terminals of the given grammar, and column wise you write down except non-terminals, don't include epsilon but add dollar. That I'll tell you when we talk about the third step. And finally fourth step, if any input grammar is there given for acceptance, then you have to do that, or else don't do step 4. Okay, so now in this given grammar we have a grammar given containing three productions. First production is E gives E plus T and T. Second production is T gives T star F or F. Third production is F gives open parenthesis E close parenthesis ID. In the given grammar there are three non-terminals. One is capital E, capital T and capital F, and terminals are all lowercase letters, digits and operators. Here terminals are plus, minus, star, and we have open parenthesis, close parenthesis and ID. Okay, now this is a given question and we have to verify whether the given grammar is LL of 1 or not. First thing what we have to do is, according to step 1, this given grammar contains left recursion. When we say it's left recursion is when the same non-terminal is appearing on the right hand side. We say the given production grammar is left recursive. So eliminating left recursion and computing first and follow, I prepared video, please look at that, then you will able to understand clearly how to eliminate left recursion and how to compute first and follow. Okay, but once again I'll tell you how to eliminate this and that. Okay, now after eliminating it, take the non-terminal which is not creating recursion. For E gives E plus T, then we have eliminated. So this is the final grammar, you got it after eliminating left recursion from the given grammar. Okay, so for eliminating left recursion and for computing first and follow, please follow other videos. where I talked about how to eliminate left recursion and computing first and follow. Okay, now computation of first and follow also. Step 2 is, yeah. So now this is the grammar E dash T dash F. For this grammar you have to compute first and follow. So E dash T dash and F. Now, okay, so computing first and follow, the first symbol that is appearing immediately for first of E means which is what are the symbols that are appearing immediately on the right hand side. We have T. For T we have F. For F we have open parenthesis and ID. So that is the reason we got it open parenthesis and ID. For E dash we got plus and epsilon. For T we got it open and ID. For T also T dash we got it star and epsilon. For F we got it ID and open parenthesis. In the same way you compute follow. When you are computing follow, that particular non-terminal symbol, look at the right side of the production where that particular non-terminal followed by what symbol. Suppose follow of E. So after E we have a close parenthesis. As it is a start symbol we include dollar. Okay, and then like this, follow of E dash. Follow of E dash is follow of E. Follow of T is follow of T is first of E dash, where we got star. First of T dash is star and epsilon. So we eliminate epsilon and then include the next follow symbol, dollar close parenthesis comma plus, and follow of T dash is also star plus color plus and for F we have follow of F is follow of T dash. So this is how you got the grammar, star plus close parenthesis and dollar. Okay, so this is the second step to compute first and follow for the given grammar. And the third step we have, this is the one that we are going to talk about. The third step, yeah, so based on first and follow we are going to create a table, parsing table. From this table we are going to tell whether the given grammar is LL of 1 or not. Okay, now this all the non-terminals of the given grammar which we have computed for E dash, T dash and F, you write it row wise, E dash, T dash and F. Column wise, what are all the terminal symbols that you got it from this first and follow or in the given grammar, which is ID, star, plus, open parenthesis, close parenthesis and dollar. Don't write epsilon when you are writing the terminal symbols at all. Okay, please don't write epsilon at all. Okay, now how do you fill this table here is, okay, so preparing a table is row wise all the non-terminals of the given grammar and column wise all the terminals of the given grammar. Okay, now look at here, we have E dash, T dash and F. So we are writing here row wise and column wise we have open parenthesis, close parenthesis, plus, star, ID and a dollar as well. So you write it once but don't write epsilon. Now how do you going to fill the table? Okay, so there are two rules actually. Rule 1 is when first of, yeah, I'll tell you when we are talking about it. Okay, now first of E is what? Open parenthesis and ID. So in the table under where we are filling it for non-terminal E. First of E is, yeah, so first of E, now we'll come from starting. First of E is, we have symbols open parenthesis and ID. So under open parenthesis, under ID, write the corresponding E production in the given grammar. Okay, so first of E there is only one production, so under ID and under open parenthesis we write down the corresponding production, which is E gives T dash. Okay, now come here, first of E dash we have plus and epsilon. So under plus we have two productions consisting for E dash, which is E dash gives plus T dash and E dash gives epsilon. So the corresponding production of plus is, which is starting with here plus. So under plus we write down E dash gives plus T dash. As we are not including epsilon in the table, when we have epsilon in first of E dash, include symbols of follow. Okay, the follow symbols are here close parenthesis and dollar. So under close parenthesis and dollar Because of epsilon, we are adding close parenthesis and dollar. So write the corresponding production as E dash gives epsilon. Okay. So when we have epsilon in first symbol, we have to look follow symbols as well. Okay. Now first of T dash, we have open parenthesis comma ID. So under open parenthesis and under ID, we write it T. There is only one production. T gives ft dash. We fill it in the corresponding cell. Now come to T dash. Okay. So T dash, there are two productions, and first of T dash is we have star comma epsilon. So under star, we write down T dash gives star ft dash, and we have epsilon in first of T dash. When we have epsilon in first of T dash, we include follow symbols as well for T dash. Okay, so follow symbols are plus, dollar and close parenthesis. So under plus, under dollar and under close parenthesis, we include T dash gives epsilon. Okay, and for F, we have open first of F is open parenthesis ID. So under open parenthesis and ID, we write down ID. We have two productions. One is F gives ID, and other one is F gives open parenthesis E close parenthesis. So under ID, we write the corresponding production as F gives ID, and for open parenthesis, F gives open parenthesis. So we write down. So this is how you fill the table. First step is you have to eliminate left recursion. Second thing is you have to compute first and follow. And third step is you have to prepare a table. While preparing a table, if first of that non-terminal contains epsilon, then only include follow symbols, or else don't include follow symbols in the table. Okay, so this is the final grammar, and we have to check whether the given grammar is LL of 1 or not. Okay, now rest of the blank entries we say error entries. Now in each cell there is only one entry filled. Okay, now E on ID, we have only one table, one cell, one entry, that is E gives TE dash. When we have more than one entry in one cell, we say the given grammar is not LL of 1. Okay, so now the given question, the given grammar is LL of 1, and the parse tree can be derived from the stack implementation of the given parsing table. Okay, so how we are going to do parse tree in implementation is, this is the grammar, right? So I'll tell you, initially when we are doing acceptance of the string, the input string is id plus id star id. We have to look at the parsing table, and then we have to do the acceptance of the string. Okay, now the parsing table is that we got it, which the table, when we based on that table we say the given grammar is LL of 1 or not. From that table we have to check the acceptance of the input string. Okay, now so by default a dollar will be there in the bottom of the stack, which indicates bottom of the stack, and by default end of the input string we have dollar, and as we say it employs leftmost derivation. From the derivation starts from root node to leaf nodes, and the start symbol of the given grammar is E. We have E in the stack. Okay, now the input string is E on ID. So E on, this is the parse table we have. Okay, E on ID. So E on ID, what we have, look at the table. So E on ID is, E is replaced with, E is the left hand side symbol, which is replaced with TE dash. So we write it TE dash. Okay, and then T dash is replaced with what? Look at the table, T dash on ID. So we have an entry T dash gives FT dash. Okay, so now F on ID. Now the on top of the stack we have F and ID. So F on ID, when we have a entry F gives ID. So always when you are replacing this in a stack, we replace left hand side symbol by the right hand side. So in the table we gives F gives ID. So F on ID means we refer the table corresponding cell F on ID. So F is replaced with ID. Now ID. So ID, when we have ID on top of the stack and the input is same, when the input and stack symbols are same, we pop both top of the stack and input. Now both are popped. Now the top of the stack is T dash, T dash on plus. So look at the table, T dash on plus. We have T dash gives epsilon. So when we have T dash gives epsilon means in place of stack you pop the top symbol. In place of T dash you put epsilon. When always replace the left hand side by the right hand side. So in place of T dash you put epsilon, which means top of the stack will be popped but not input. Okay, now we have E dash. T dash is already popped. Now we have E dash on plus. So E dash on plus, look at the table, we have E dash gives plus T E dash. So left hand side symbol E dash is replaced with plus T E dash. Okay, so in place of T E dash we got it plus T E dash. We write it here. Now top of the stack is plus and input is plus. So when both are same, we pop top of the stack and input as well. Okay, so now this is how you write it. So these are the stack symbols and this is the input and this is the action. Now finally when the input is empty and stack is empty, we say string is accepted. Okay, so this is how you create a parse tree or you do it. Okay, now let us take it one more example. We have s gives IETSS dash a. So we have left factored, we have eliminated, and the next thing is we have computed first and follow, and then after computing first and follow we are going to prepare a parse table s dash e for all the non-terminals. Now s on first of s we have a comma I. So under a and I we write the corresponding productions. First of s dash we have e and epsilon. So under e we write down s dash gives as. Under epsilon, because of epsilon we have follow, which is e comma dollar. So under e comma dollar we write the corresponding production. Now first of e is b, we write the production. But what happens here is we have two multiple entries in s dash of e. As we have multiple entries, the given grammar is not ll of 1. Okay, so this is how you verify whether the given grammar is ll of 1 or not. Okay, hope you understand.